G'day everyone, welcome back to TechForce Arena. If you're new here, make sure to hit that subscribe button, because today we're diving into one of the most legendary and precise long-range weapons ever built, the Tomahawk cruise missile. This piece of military tech has been flying under the radar, quite literally, for over 4 decades, yet it remains one of the most effective and reliable tools in modern warfare. So grab a cuppa, settle in, and let's unpack what makes the Tomahawk such a game-changer in military technology. The Tomahawk is a long-range, all-weather, subsonic cruise missile. In plain English, that means it can travel thousands of kilometers, hug the Earth to avoid radar, and strike targets with pinpoint accuracy, all while being fired from ships or submarines hundreds or even thousands of kilometers away. It's developed by Raytheon, a major US defense contractor, and it's been in service since the early 1980s. Despite its age, it's been upgraded so many times that the latest versions are basically brand new weapons inside the same iconic shape. Let's roll back a bit. The Tomahawk was originally designed during the Cold War, when the United States wanted a weapon that could hit Soviet targets from a safe distance. Back then, accuracy was a huge problem for long-range weapons. Missiles could travel far, but hitting the exact building, bunker, or launch site was another story entirely. The Tomahawk changed all that. Its secret sauce was its guidance system, which, at the time, was revolutionary. Instead of relying solely on GPS or radar, it used something called TERCOM, terrain contour matching. The missile carries detailed maps of the ground below, compares them to its radar altimeter as it flies, and constantly adjusts its path to stay on course. That means even without GPS, the Tomahawk could find its way to a target across complex landscapes. Later versions added GPS and something called DSMAC, Digital Scene Matching Area Correlation, which basically lets the missile compare real-time images with stored pictures of the target area. It's like giving the missile a brain and a memory card. It recognizes what it's supposed to hit. Now, how far can it go? The range of a modern Tomahawk sits around 1,600 to 2,500 kilometers, depending on the model. That's roughly the distance from Perth to Cairns, without refueling, without being detected, and without a pilot on board. The Tomahawk flies at about 885 km per hour, which is just below the speed of sound. It's not the fastest missile out there, it's subsonic, but that's by design. Flying slower actually helps it stay stealthy, slip under radar coverage, and weave through valleys and mountains. In terms of payload, the classic Tomahawk carries a 450 kg high explosive warhead, or in some cases, a cluster of smaller bomblets. Earlier versions could even carry nuclear warheads, though those have been retired. The missile's power comes from precision. It can fly into a window, not just hit a city block. That accuracy makes it a go-to choice for strategic strikes. It's been used in conflicts from the Gulf War to Iraq, Afghanistan, Libya, and Syria. Whenever you hear about a US or UK Navy destroyer launching a precision strike on enemy infrastructure, odds are good that Tomahawks were involved. So, what makes the Tomahawk stand out even today, in an era of hypersonic missiles and drones? The answer is flexibility. The Tomahawk can be fired from a range of platforms, surface ships like destroyers and cruisers, or from submarines while they're deep underwater. Once launched, operators can even reprogram the missile mid-flight. That's right, they can change the target while it's already in the air. Imagine a missile flying for hours, getting a message saying, "New target ahead," adjusting its route, and striking a completely different location, all autonomously. That's the level of smart tech we're talking about. The Tomahawk Block IV, for instance, introduced two-way satellite data links, allowing operators to see what's happening, receive missile status updates, and give new commands mid-flight. And the next generation, the Tomahawk Block V, takes it up another notch. This version includes upgraded navigation, hardened electronics to resist jamming, and even better targeting algorithms. There are 2 sub-variants, the Block VA Maritime Strike model, which can target moving ships, and the Block VB, designed to penetrate hardened bunkers and defenses on land. That ability to hit both land and sea targets makes the Tomahawk one of the most versatile cruise missiles ever built. A Tomahawk is around 5.5 meters long, weighs roughly 1,600 kilograms, and is powered by a small turbofan engine, similar in concept to what you'd find in a jet, but built for efficiency over raw speed. At launch, it's boosted out of its canister by a solid rocket motor, which drops away after a few seconds, and then the jet engine kicks in for the long flight. It deploys small wings to stabilize itself and uses tail fins for steering. The internal computer handles all flight adjustments automatically. This is where the Tomahawk shines. It's not just a flying bomb, it's a self-navigating robot that makes thousands of micro-decisions on the way to its target. Now, let's look at why the Tomahawk is still relevant in 2025. With all the talk of hypersonic weapons, you'd think a slower, subsonic missile would be outdated. But in practice, hypersonic missiles are incredibly expensive, and their heat signatures make them easier to detect. Tomahawks, on the other hand, are proven, reliable, and cost-effective. They can be deployed in huge numbers and overwhelm defenses through sheer coordination and stealth. The US and UK navies keep hundreds of them ready for launch at any moment. Plus, with the new Block V upgrades, they'll remain in service well into the 2040s. For Australia, this is particularly relevant. The Royal Australian Navy announced plans to equip its Hobart-class destroyers and future submarines with Tomahawks. That means Australia will gain a long-range strike capability for the first time, the ability to hit targets from thousands of kilometers offshore. That's a big leap in deterrence and defense power. It gives Australia a genuine reach across the Indo-Pacific and a credible response to emerging threats. So when you hear about Tomahawks in the news, remember, they're not just old missiles from the Cold War. They represent decades of engineering evolution, from early guidance computers the size of a fridge to today's smart, retargetable, satellite-linked precision weapons. They bridge the gap between traditional cruise missiles and modern autonomous strike systems. To wrap it up, the Tomahawk isn't flashy, it's not hypersonic, and it doesn't look futuristic. But that's what makes it such a legend. It's a weapon that just works, time after time, mission after mission. It's accurate, dependable, and constantly upgraded to stay relevant. Whether it's striking enemy radar sites, command bunkers, or warships on the move, the Tomahawk remains one of the most trusted tools in modern naval warfare. And as we move deeper into the 21st century, it's clear the Tomahawk's story is far from over. Thanks for watching, legends. If you enjoyed this breakdown, give it a thumbs up, subscribe to Techfus Arena, and hit that bell so you don't miss our next deep dive into the tech that shapes our world. Catch you in the next video. Stay curious, stay sharp, and as always, keep exploring the force of technology.